Okay, we are going to do another section in chapter 13. We're doing section 13.4. And this section in 13.4 is just extending what we already did in section 13.2, where we did a few velocity and acceleration problems. And I talked to you about what actually vector valued functions really are. We talked about what they were, and we did a few problems of finding different derivatives and integration of vector valued functions. And then that kind of extended into already talking about velocity and acceleration. So now we're going to do section 13.4, which extends it even further into speed, displacement, and distance traveled. So our outcome is I can solve motion problems. So this is more specifically talking about the movement, all right, motion of vector valued functions. So this is the only two sections we're going to do in chapter 13. This is called our unit 3. And then we'll move on to unit 4, and we're having a combined test over the two. Okay, so the first thing here, we have our velocity vector, which we already talked about in the last section, but I'll review it just again. The velocity vector is your tangent vector because the velocity vector is the derivative of the position vector. And we know the first derivative is always talking about your tangent. So if we have a position vector, r of t, then the velocity is r prime of t, which is the derivative of each component of that vector. So r prime of t is the tangent vector to the curve at point P, and your tangent line at point P is just going to be a line through P parallel to that tangent vector. The acceleration vector we've already worked a little bit with. Our acceleration vector, when you're given your position, you know the first derivative is velocity, and then the derivative of velocity, which is the second derivative of your position, is going to be your acceleration. So your acceleration vector is going to be x double prime and y double prime. So here's your new stuff, speed. Speed is the absolute value of velocity, okay? The absolute value of velocity. So, and the absolute value, and we know velocity is r prime, and the absolute value of r prime, in order to get that absolute value, that's the magnitude of the velocity vector. Okay, the magnitude. So speed is the magnitude of the velocity vector. So you're going to take dx dt and square it and add that to dy dt squared. So this is a squared plus b squared. It's Pythagorean theorem. So it's doing magnitude on the derivative on your velocity vector. So that's your speed, the magnitude of the velocity vector. And this looks somewhat familiar. We've seen something similar to this before. So speed's the magnitude or the length of the velocity vector and the rate of change of distance with respect to time. Okay? So now what's displacement from T of A to T of B? Now we talked about in previous classes the difference between displacement and your total distance traveled. So I just want you to remember that. Displacement is how far you are away from where you started. But the total distance traveled is how far you've moved total altogether. All right, so you may have moved back and forth, and you may have moved 2 units left and 2 units right, but then your displacement is 0 because you're back where you started. So displacement and total distance traveled, just remember the difference between those two things. So displacement. When you're doing displacement here with our vector valued functions, the integral of a to b of x prime, so you're integrating your velocity x component and you're integrating the y component of your velocity vector. So you're integrating x prime and you're integrating y prime, given the position vector rt. All right, so this is going to give you a change in position. So the integral of x prime and the integral of y prime gives you your change in your position. So it tells you how your x component changed and how your y component changed. So this vector has to be added to your position at time A to get where you are now at time B. Okay, so this just tells you your displacement, how much you've moved. So how has your x coordinate changed? How has your y coordinate changed? So you add this component to your starting value at t equals a to get where you are now at t equals b, if that makes sense. All right, so this vector is added. Yeah, exactly what I said down there. So that's displacement. Now, how do you get your total distance traveled? All right, your total distance traveled from t of a to t of b for any position function, R of t, that distance traveled is going to be the integral of your speed. So when you accumulate and add up all of your speed, then you're going to get your total distance traveled over time, right? Now, this sounds familiar. This looks familiar. This is the same as the arc length. We've already done problems like this. So this is all still parametric equations. It is really no different. They're just written in a different format. They're just written in vector format as opposed to having two different functions, a y function and an x function. So this is really not new information. So distance traveled is the same as your arc length when we did parametric curves. All right. So without the integral, that's your speed. And then when you integrate your speed, that's your total distance traveled. All right. So that is your content video part for this section 13.4.